In the previous video, we were working on sliders and progress bars. Today, we are going to create our first custom control toggle button. In UI Project UI Resources folder, create a new folder called Toggle Button. In this new folder, create new UI document and name it Toggle Button, and open it in UI Builder. Set its size to 120/60 pixels. Put a visual element to the hierarchy and rename it as background. Create a new USS file, name it toggle button USS, and save it in the toggle button folder. Delete the root. Create background style selector and set flex direction to row, justify content to the center, spacing padding to 5 pixels, background color, border width to 3, and border radius to 30 pixels. Then apply this selector to background visual element. Create another visual element inside a background and name it toggle. Then create a new selector called toggle active. Now set the toggle active selector properties, flex grow to 1 and direction to row. Align items and justify content to the center. Background color, and border radius to 20 pixels. Create another selector toggle inactive and apply it to the toggle element. Now set its properties, flex grow to 1 and direction to row. Align items and justify content to the center. Background color, and border radius to 20 pixels. Now selector is label on with properties, text font style bold, size 25 pixels, and this color. The last selector here is label off with properties, text font style bold, size 25 pixels, and with this color. Put one label into toggle visual element and name it status label. Apply label off selector to status label and set its text attribute to on. For custom control, we also need to create a new C# script. Name it toggle button. Delete everything what we currently have inside a class and add using Unity engine.UIElements namespace. Class has to be partial. We don't need mono behavior. We need to let Unity know that this class is a custom UI Toolkit element that can be used in UXML and shown in UI Builder. This can be done by adding UXML element attribute before the class definition. This will also allow UI Builder to show this control in the library. For this new control to be part of the UI Toolkit, its class needs to inherit from Visual Element class. Visual Element class is base class for UI Toolkit controls. Every UI Toolkit control inherits from it. In other words, Visual Element class is the core building block of UI Toolkit. By inheriting from Visual Element class, our control gets many UI Toolkit features for layout, positioning, styling, hierarchy, events, rendering, and so on. The next challenge is to make this custom control somehow notify the parent UI class ShipUI in our case when the toggle is pressed. Thus, custom control will implement iNotify value changed interface. Since our toggle state can either be on or off, value will be bool type. This way UI Toolkit knows that this element has a value, it produces change events, and supports value change callbacks. With that, register value changed callback becomes available. Then we will create variables that will hold the references to the UI elements we used in UI Builder of this custom control. We also add a few more variables, value, which is the actual logical state of the toggle, and variables for default width and height of the control. Now create a constructor. First, we have to load the visual tree asset from a resources folder. A visual tree asset is basically a UXML template asset. It stores a tree of UI elements that can be cloned into the live UI. Then for safety, we check whether the UXML template was successfully loaded. If it's loaded successfully, then we take the structure stored in the UXML asset and copy it into this toggle button instance. After clone tree, toggle button object now contains those children in its hierarchy. Next, we query the important child element. Now we let Unity know that this element should respond when the mouse pointer is on it. We want the user to click the visual toggle area, so it needs to participate in pointer picking. If an element is not pickable, pointer events may not reach it as expected. We're using a pointer event because we want to toggle to react immediately when clicked or tapped. And then we need to catch the pointer press input. The function argument is a lambda expression. It just means ignore the event object and flip the current value. Now we want to make sure the visual appearance always matches the internal state value. And we do this with these two functions we will now work on. Apply size function is responsible for synchronizing the layout size of our custom control with the value stored in track width and toggle height. First, we set the size of root control, and then we prevent shrinking because flex layouts can shrink elements without minimum sizes. Then we make sure the background element always fills the entire control, and let the toggle sizes automatically. Set value without notify sets the initial visual state of the control. It does not send a change event. We want to initialize the visuals without telling the rest of the UI that the user changed the value. This is function iNotifyValueChanged interface expects that we implement. So we are updating the toggle's value without sending a change event. And after changing the internal state, we must update the UI, because value itself does not automatically update the visuals. Update visual function just updates the visual appearance of the toggle based on value by adding and removing selectors and changing the label text depending on the toggle state. Enable in class list adds the class selector if the condition is true, otherwise it removes it. This constructor is the setup phase of our custom control. It builds the internal UI, finds the important child elements, wires input, then applies the initial size and state. Now we continue with a piece of code that is actually the heart of this custom controls value system. It connects the internal state value, the UI visuals, and the UI Toolkit event system. First, we will set attribute and let Unity know that this property can be set from UXML or UI Builder. Then we declare property named value. It represents the current logical state of the toggle. Next, we add a getter. This simply returns the internal field value. Then there is a setter. It runs whenever someone assigns a new value. First, we prevent any redundant updates, stores the previous value, and update the internal state without triggering an event. So this will update value and your appearance, but it does not send an event yet. Then we need to create a change event object. It represents the value changed from previous to a new value. And we set the event target, which is basically this toggle button, so the listener knows which element triggered the event. And then just send the event into the UI Toolkit event system. The event will propagate through the UI hierarchy, and listeners can catch it. And lastly, we will create and expose two more properties for toggle height and width. These will control toggle size from UI Builder. Whenever they change, they immediately update the control size by calling apply sizes and set internal variables that track width and height. The first property is for height and then for width. That's all the code we need for this custom control. Back in our ship UI, add another visual element to the lower panel, rename it as toggle panel, and sets its properties. Flags grow to 0, align items to the center, and size 250 by 300 pixels. Add a label in toggle panel, rename it as shields label. Apply the text selector on it and change its text attributes to shields. Now in library, switch from standard controls to project and under custom controls C#. You should find the toggle button we just created. Just drop it in the toggle panel below the shields label. Rename it as toggle shields, and under attributes set its height to 80 and width to 200 pixels. We can now just duplicate both label and toggle button, rename the new label as warp label and set its text attribute to warp, and the new toggle button as toggle warp. There is one slight issue. Off text is not centered. We can fix this quickly by opening back toggle button control in UI Builder. And for toggle inactive selector, just align items to the center. Now we can finish the rest of our UI. In the upper panel, add a new visual element and name it upper left panel. Let it be above the ship visual element and set its properties. Flags grow to 1, justify content to the center, size width is 150 pixels, spacing padding 30 pixels. Put a label in it, name it Hull Integrity, and apply text selector on it. Its properties are space padding 5 pixels and align text to the center. Set its text attribute to Hull Integrity. Now duplicate any progress bar we already created and drop it below the Hull Integrity label. Rename it as Integrity Progress. Duplicate the label Hull Integrity, rename this one as Hull Integrity Value, and set its text to 75%. We just need to add one more visual element to the right of the ship image. Name it Upper Right Panel. Set its flags grow to 1, align items and justify content to the center, and its width to 150 pixels. Add another label named Red Alert Label, apply the text selector on it, and set its text to Red Alert. And last, add one more toggle button below this label and name it Toggle Red Alert. Set its height to 100 and width to 400 pixels. Now we can update our main C# script. In today's video, we're going to enable toggling the shields. We're going to create a variable that will hold reference to toggle shields, toggle button, and ship image visual element. Then we save exact UI elements to variables, and we register its callback function. In the callback, we just switch selectors that hold ship images. One has a ship image without a shield, and the other one with shields. Now we can check what we got. Pressing on the custom toggle button allows us to switch between two states, shields off and shields on. This confirms the toggle custom control works properly. In the next video, we will add animations to the shields and warp toggles. We will also dynamically change the UI theme when the red alert is active. And finally, add some sound effects. See you in the next video.